Okay, let us see this next example here. It says a hemisphere of a ball of internal radius 2r is fixed with its circular rim. When we cut a sphere into two, we form what we call a hemisphere. So, internal radius 2r is fixed with its circular rim at the top. When you cut it into two, that top we make what we call a rim. Horizontal. A particle B is moving in a horizontal circle of radius r on the smooth inner surface of the bowl. So if P is moving with a constant angular speed omega, show that W is equal to that. So start with a simple sketch. So I'm going to say this is going to be now my horizontal rim, as you can see there. Okay, of course, the reason with that, now I'm going to be having the other end of the bound in that order, as you can see. So that's now my bound. I think we see something similar to hemisphere. Then from here up here, we are telling me that this radius is 2r. Now inside here we have the particle now moving in a circular path. Of course, they are giving us a radius. So from here up where this particle is, we are going to be having radius r. Of radius moving in the circle of radius r. So we have a particle P here of the mass we don't know. Now for it is moving in a circular path like that. So that's the case we are having. That's the way that particle is moving. So this is our particle P. Of course, it's going to be having a mass falling under there. Now, because there is contact between this particle and the surface, so we are going to expect a reaction, and reaction is always perpendicular to the surface. So this is our reaction here. That particle, so we are going to be having our reaction there. That's going to be our reaction. Okay, now from here, I can say this is one here. If I can everybody there. Now you know from here up here, it's going to be R to R. From here up here, it's going to be to R. Of course, this is going to be perpendicular to that. Now, if I call this angle here theta, I can pull out this, let me call this the center. So I can pull out this triangle there. Then let me pull it so that I can have a clear view of it. Now, from here, this is my theta. So it's that from here up to here, this one radius r. Now, you note, from here up to here, it's the same as from here up to here, because a sphere has its radius equal in all, I mean from the center up and inside. So if it's a sphere, from here up here is 2r, and from here up here is 2r. This one is going to be 2r for a sphere. Okay, so this one we don't know. So from here we can get this angle. So you can see that from there, my cos theta is going to be equal to the adjacent over the hypotenuse. From there, it's that my theta is going to be 60 degrees. So, meaning, now I have this as 60 degrees, this angle makes it horizontal. Now, can you try to resolve vertical? Now, if I draw another diagram for this arm, basically, because I have now my theta there. If I draw this diagram again, based on now the angle I have there, so now I have this, hope you can see it. Then I have R. I have the reaction R. So this angle here now it's in is 60 degrees. Now from here I think you see, okay, from here I had it as a half with the easy. So now from here, can we resolve this? You can resolve this. When you resolve this first, this is adjacent, so this is going to be R. Because it's adjacent goes with cos of 60. Then this one here is going to be the vertical component of R, which is going to be R sine 60 this. Or if you never wanted this, you can get this, because this is going to be for R, this is going to be R, then this would have been R root 3. That was the other way how you can handle this. It's up to you. So from there, you can see that, or you can see that cos theta, for it is a half, and then sine theta, for it would have been the opposite over the hypotenuse, which would be root 3 over 2. So either way you take to give you the answer. Now, if resolved vertically upwards, now it means that this force here, if I resolve this now, it's going to be, so this force here is going to be R. Now it's opposite, sine theta. Then here I'll be having R cos theta. So if I resolve vertically, it's that my R sine theta is going to be equaling to, it's going to be equaling now to mg with ease. So I call this equation 1. If I resolve horizontally in this order, going left side, I'll be having R cos theta equaling 2. We say this one is, whenever we resolve horizontally, it's going to be equal to the centripetal force, F, which is equal to M d squared over R. So here they gave us now the angular, this, which is equal to 2m omega squared R. Take the note that V is equal to R omega. So from there, you can establish that my R cos theta is going to be now omega R, and this I call this equation 2. Now the one that said that omega is equal to that. So the one that said that omega is going to be equal to the square root of that. So from here, you can see that we can ably determine R. We have this. We can now make omega the subject from here. So you can see that now my omega, I have R cos theta, the whole over. When I get this, divide this side, I have M R equaling omega squared. Now, can we remove this R? We are going to remove it using this. So you can see that from there. So from one here, from 1, you can see that now my R is going to be, my R sine theta equaling to md. My R times sine theta, we've seen is the root 3 over 2 equaling to md. You can multiply, so our R there is going to be 2 md over root 3. So meaning, I call this one equation 3. So if I have that as equation 3, I can ably put it here, and I get my omega. So from here, if we put everything from here, so my R, my omega is going to be, now this is going to be 2 md over root 3, then times our cos theta, which is a half, the whole divided by mr full stop. So from there, I think you can see that this one is going to go with this, then this half is going to go with this. So I'll be remaining with now omega equaling to, this is going to be d over root 3r. So can you rationalize this, which will be the same as d over root 3 r times root 3 times root 3. And so it's that our omega squared from there is going to be d root 3 over root 3 times root 3 gives us 3. We get the square root. Now our omega will be the square root of d root 3 over 3r as the proof. You can see it there. You can see it there. So this was our part A. Then we come to part B. So in part B, they want us to get the omega if the radius of the hemisphere. Now, they are giving us the radius of the hemisphere. So from here up to here, they are telling us now it's going to be, they are telling us now R to R is equaling to 2 over 15 root 3. So see that from there, my R is going to be root 3 over 15. So coming from here, now my omega will be the square root of, now our new, we know, it's 9.8 times root 3 over 3, now times the radius, which is now going to be is 2 root 3. I wanted to make it anyway, which is going to be root 3 over 15. So you can able to see by this one, by this, it's going to be 5. This goes and this goes. So this will be giving us 9.8 divided by, this is 1 over 5. So our omega is going to be now 9.8 times 5. So our omega comes 7. Is it because this is going to give us 49? So, which is rad per second. So that's our omega there. Now after getting that, you can establish that my velocity, the linear velocity, so it's given by radius times the angular velocity. So my radius here is root 3 over 15, then times 7. And so this one is going to give me 7 over 15 root 3 meters per second with ease. So that's how we had to handle that number with ease. I wish you well.